Students, in the unit 3 we are going to discuss about the magnetic field. First unit speaks about the static electric field. Unit 3 and 4 speaks about the static magnetic field. When we speak about the electric field, the analysis is spoken in terms of the Coulomb's law. When we speak about the magnetic field, the basic definition is dealt in terms of Biot-Savart's law. You would have learned this in physics. By definition of Biot-Savart's law, the magnetic field intensity, which is defined by differential magnetic field intensity dH, is directly made proportional to the product of this is a current element, this is a current carrying conductor. You are choosing a differential line element of dl. It makes an angle of alpha with respect to point P. It is at a distance of r with respect to point P. Now, by definition of Biot-Savart's law, dH or the differential magnetic field intensity is directly proportional to the product of the current element and the sine of the angle which it makes with respect to the point P, and is inversely proportional to the square of the distance between them. So, removing the constant of proportionality, we have k. So, dH becomes equal to k into IDL sin alpha divided by r square, or k is equal to 1 by 4 pi, which is the constant of proportionality. Now, dH is defined by IDL sin alpha divided by 4 pi r square, because k I have replaced by 1 by 4 pi. But in vector form, how do we define this? It is dH equal to IDL cross AR vector divided by 4 pi r square, or IDL cross R vector divided by 4 pi r cube, because we know that AR vector is equal to R vector by R. Here cross defines the sine angle. We know the cross product is sine representation and dot product is the cosine representation. Now we can define the same analysis in terms of continuous sources as H is equal to, dH is equal to, we have identified, so H becomes equal to integral of IDL cross AR vector divided by 4 pi r square for line element, replaced by double integral KdS for surface element, and replace this IDL by triple integral JdV for volume element. So the line element, surface element and the volume element are shown. However, the direction of dH can be just determined by using the Fleming's right hand rule, with the thumb pointing the direction of current and the fingers encircling the wire in the direction of H. And this is the basic definition of Biot-Savart's law. Now, we will learn the repeated university question of this analysis. Magnetic field intensity on the axis of circular loop. What all we have learnt in electric field intensity, parallelly we are going to learn the magnetic field intensity analysis. Now, I am considering a circular loop. Okay, it is centered at the origin. It is placed in the XOY plane. Now, it is carrying a current of I is imagined. Consider a point P purely lying on the z-axis, and now the differential line element is placed in the XOY plane. So, r, phi, 0 is a point of line element, and a point P is defined by 0, phi, z. We all know very clearly the cylindrical ordinate system has a representation of either rho phi z, or some of the books denotes r phi z. We prefer the r phi z representation in this analysis. So the corresponding unit vectors are AR vector, A phi vector, AZ vector. Corresponding line element is written over here. Now I have to write the differential line element. We know for the cylindrical ordinate system, it is dr of AR vector plus r of d phi of A phi vector plus dz of AZ vector. dl is nothing but equal to. Now listen carefully. This is the line element. I don't have A phi component. I don't speak about the AR component and AZ component, because dr is equal to 0. When r is a radius, dr is differential radius, which is equal to 0. Also z is equal to 0 is defined in the plane itself. So dl element becomes equal to r d phi of A phi vector alone. So though in the beginning we speak about all three elements, it is very clear that r is a constant, radius is a constant. So dr becomes equal to 0. As it has no z component, it is purely lying in XOY plane, dz is also equal to 0. We are left out with r d phi of A phi vector. Now, we know that the point is located in the condition of z-axis as 0, phi, z. I can identify the difference between these 2 points, that is with respect to the point P and the line element dl. So, 0 minus r, minus of r, AR vector, plus phi minus phi 0, plus z minus 0, z of AZ vector. So, r vector is equal to minus of r AR plus 0 A phi plus z of Az. So AR vector directly I have written r vector divided by R is mod of R vector, so root of R square plus Z square. We know by definition of Biot-Savart's law, dH is equal to IDL cross AR vector divided by 4 pi R square. So I can replace I, dl element I know, R d phi of A phi vector divided by 4 pi of R square plus Z square in the place of R square into AR vector cross, it is not into, it is cross, minus of R of AR vector plus Z of AZ vector divided by root of R square plus Z square. Now, by mathematics, we know very clearly that A phi cross AR and A phi cross AZ, you know very clearly AR vector, A phi vector, AZ vector. When I do the cross product of AR and A phi, it is AZ vector. When I do the cross product of A phi cross AR, it is minus of AZ vector. That is what I have written over here, minus of AZ vector. Same way A phi cross AZ. A phi cross AZ is AR component. Now we can learn in this analysis, AR vector is horizontal component, but the circular loop is placed in the horizontal plane. So taking the integration, AR component does not exist, which means that AR is cancelled out. We have only this component existing. So I write H vector is equal to integral of this value. This is actually dH, left hand side is dH. So from this I need H value. So it is I R square of d phi. This is minus AZ vector. Already one minus is there. So minus of minus plus AZ vector 4 pi R square plus Z square the whole power 3 by 2. We know in cylindrical ordinate system phi has a default limit of 0 to 2 pi. So I R square d phi with respect to 0 to 2 pi, rest all components I have taken out. Integral of d phi is nothing but equal to phi, 0 to 2 pi, which is 2 pi minus 0, which is 2 pi. Cancel out the like terms. I am left out with I R square AZ vector divided by 2 into R square plus Z square power 3 by 2. Now if I am assuming that the point P is being placed at the origin of the conductor, then it means that Z is equal to 0. Substitute Z equal to 0 in this equation. So it becomes 2R square of power 3 by 2 or 2R cube. Cancel out the like terms. The final equation takes up the form of H vector is equal to I by 2R of AZ vector is the magnetic field intensity due to the circular ring. A repeated university question. You can learn through this. Thank you.